Okay. Mr. Romanes, are you ready? Okay. Good morning, everyone. My name is Nita. I am a software developer here at Glodon, and I will be one of your trainers today. My partner. I'm working with my partner today. His name is John, Mr. John Amutenya. He will be. The two of us will be hosting this training and presentation. I will be mostly focused on the theory aspect of the training, and I will be beginning with everyone. Mr. John will take up the practical session of the training. We are really excited for everyone to be here, and we hope you are going to have fun and you are going to learn a lot as we all learn together. Can I maybe just say hello to everyone? Just tell me what school is you are representing. If you are a teacher facilitating this, how many learners do you have with you? Yeah, maybe we can just start with Miss Dr. Romanes Kapungu.
Good morning, ma'am. How are you?
Very well, thank you, sir. How are you?
Very well, thank you, ma'am. It's Mr. Makusha here, Dr. Kampongo,
Uh-huh.
the teacher participating in this Scratch, what is it? Scratch code,
Okay.
programming.
Yes.
It's only that it's unfortunate it is classes time that many learners will not attend, but at least roughly 15 or 20 or so, some they are still to come.
Okay.
We don't have a fully fledged lab. It's a computer lab. We have small laptops, but they are not installed on the desks. That's why they might not participate that much. We are only one one that we are using to project a issue about that.
Okay. Do you by any chance have connections to the ones that are connected offline? Do you have Scratch installed on them, or they are going to? Do they have access to the internet?
What the?
The few laptops that are available for students to be practicing on. The few laptops that are available for the students to be practicing on. Or you are saying there is only that one laptop available?
Yeah, there are some small laptops available. I don't know what they are to practice on about, but they will give some to them.
Oh, okay. Are they able to connect to the internet, or do they already have Scratch installed?
No, they.
Okay. Don't worry about it. I think I will just then go through that a little bit in terms of just the installation, how Scratch looks like, and also Mr. John will also do a little bit of that because essentially, if you want to use Scratch offline, like not connected to the internet, you do need to install it on the computer first. Otherwise, you can use it directly on Chrome, Google Chrome on the internet. But welcome. You said you are representing which school?
Dr. Romanus Kampungu.
Oh, okay. Um, I'm very sorry. When you say Dr. Romanis Kampungu, I'm thinking it's the name of a person. Okay, it's actually a name of a school. Okay. Welcome, guys. Welcome to all the learners at Dr. Romanis. We are really super glad to have you. Okay, and I see a few students. The laptops that are added as students. Is it from Dr. Romanes as well? Are these the students logging into the meeting? Hello, can anyone with the name student who's logged in just say hello? I see some students logged in, and there's just students on there. I don't know now if it's the name of a school, or if it's a school, or yeah. Can someone just say hello? Unmute your mic and you say hello.
Hello, hello. We can hear you.
Great, great. Okay, thank you so much for that. You are also from Dr. Romanes, or which school are you from?
We are Oganja Secondary School. We are still trying to set up. That's why you can hear there's a lot of noises at the background.
Oh, okay, okay. No, I think it's because there are multiple laptops connected in the same venue. It causes interference. Okay, okay, but that's fine. Okay, okay, okay. I am admitting all the students, but I believe because if you are all in the same room, then you can't really be speaking because then they will be hearing that noise if everyone is logged onto the meeting. Okay. And that was
no. What do you suggest? What do you suggest then? Do we unmute the computers of the students, or do we just decrease the volume, or what? What do we do?
Okay, is one of the computers that connected to a projector that everyone can see? Mr. Hoa, is it Hoa Josep? I'm sorry.
Hoa Josep, yeah.
Okay, yes, Mr. Hoa Josep. Is there one projector that everyone can see the training from?
Yeah.
If that's the
So
case,
the rest, the students' computers, I can
yes.
disconnect them, and then we can just make use of one computer.
Yes, but then they just need the computers for practicing. They don't need them really for tuning into the meeting unless you don't have a projector where students can be able to view the training.
Okay, yeah, just disconnect all those. Disconnect all those. Yeah, that's all.
Okay. I also see a Grace Tairu or Tiru. I'm very sorry if I pronounce your name wrong. Can you say hi? Okay. Grace is still logging on. Okay, I don't see their mic.
Yeah, all of them. Just disconnect all of them. The students only need computers for practice.
Okay, and Mr. Khwakoseb, you said which school are you representing?
Okahanja Secondary School.
Okahanja, okay. Great. Thank you, Dr. Romanes and Okahanja. We are super glad to have you in this training. Please feel free to engage. We want the learners to be free as much as possible. Yeah, so that we can have a really interactive and good training that's productive and everyone can get out of here with something.
Okay.
I do see Grace was raising their hands. Yes, Grace. I don't know if your mic is connected because I cannot see it on my side, but feel free to say hi. Okay. Okay, we are going to continue. Okay, so essentially, Africa Code Week is an initiative by SAP, which is a software company that produces financial softwares and all these other partnership to be able to facilitate. And we just want to empower African youth with coding skills. That is the main aim of Africa Code Week. So every year between September and October, we generally hold Africa Code Week throughout Africa in all the countries that are participating. Okay. Let me teachers. Okay, today's agenda, we will just give a brief introduction to ACW, which is short for Africa Code Week. We will then also do a little bit of an introduction to computational thinking. Then we will go into the Scratch training, mostly just basic practice and at least one advanced exercise. We will then do a wrap up and look a bit also on Blockly, which is almost similar to Scratch. Okay. Okay, so essentially, welcome to Africa's largest digital literacy initiative. Aim really is to create opportunities for young Africans to learn how to code for free, and we want to help teachers to be trained in digital learning curricula across the continent. So far, up until 2019, we have had engaged 3.85 million youth around Africa and 39,000 teachers. Okay, in Africa Code Week is an initiative that supports the United Nations Social Development Goals or Sustainable Development Goals. And these ones are essentially just saying that it takes an empowered village. This is the mission of Africa Code Week, is that it takes an empowered village to raise a child in the digital age. And us as Africans, we have this whole loving and community raising of children. And we do know that, yes, we can raise them as a community, but we also need to raise them in the digital age. And we are saying the power of togetherness cannot be overemphasized. There is nothing we can do on our own. So we are delivering this training, but we still want kids, we still need the learners and the youth to be able to go out there and improve their coding skills for us to really make a big impact. And we are also saying that we don't want any child left behind. So every child that wants to get into the software industry or become a software engineer should have the opportunity to do that. And it really starts from when you are young. Okay. So Africa Code Week started in 2015, and it has been going up until 2019. So this year would be 1, 2, 3, 4, 5, 6. So this year will be the 7th year that we are conducting Africa Code Week, and we just hope to be able to engage more and more people as the years go by. This year we also had what we call African Code Challenge, where various learners could be able to compete at the national level and also at the African level by creating games using Scratch. So if you are learning your coding skills this year, so next year you could perhaps also participate in any of the challenges or competition we will be hosting with Africa Code Week. And then okay, I just need to mute. Okay, Mayara Combined School, welcome. I'm just putting you on mute because we have started, but do feel free to unmute yourself if you have a question. Okay, thank you. Otherwise, can we all keep our mics on mute unless we need to ask a question? Then you can unmute yourself and then mute yourself again. Okay. Yes, as I was saying that we do have various competitions. So this year was very exciting. We already have 3 teams from various schools in Namibia that has won the national competition, and they are going to participate in the African competition to compete with other African schools. Okay, our aim really is to change lives, and we know that if we all gain skills, it means that we will be able, those skills can help us change our lives. Okay. And we want to enable teachers like never before. So we need to, according to Ryan, who's the MD of SAP Labs, he does say that adequately preparing teachers and students for future work is the work that we all need to do, because as time goes by, we need our teachers to be able to teach us the things that we would need as we get into our future. Okay. In terms of our classroom guidelines, even here today or any other coding classroom guidelines we all want to adhere to is that we want to create gender balanced groups. So as many boys and as many girls should be engaged in coding. We want to have collaboration. And collaboration is very important because when you are creating a certain software project, you always need help of others. in terms of even ideas, so that you are able to create something that is successful and something that is useful to the community. We want equality. We are for respecting one another. We want to be able to take turns. And you want to also observe the teacher. So when the teacher is teaching you certain things, please do observe them. We want to have a safe environment. So this safe environment goes well in with respect, where we're saying that if I don't know how to use a mouse, then I should be able to say I don't know how to use a mouse and someone can help me. So we really do want to foster a safe environment. And we want to have active listening and assigning roles, especially in projects. Software projects really need assigning of roles, like someone maybe code this part of the project, the other person code that part of the project. We also want non-stereotypical roles, which means that there's no such thing as this part of the project can only be done by girls or this can only be done by boys, but all of us can be able to take certain type of roles. And we also want group dynamics so that everything is just not on one part of the team or etc. So these are some of the classroom guidelines we are always enforcing, or we are always fostering and encouraging that we should always have these classroom guidelines whenever we are engaging at levels like this or having coding lesson plans or coding lessons at our school. Okay. For this training particularly, we, like I said before, we have two parts. We have a computational thinking part, and we have a practice part of Scratch. So when John is gonna go through the practice part of Scratch, for those that have installed Scratch on their computers or that can go onto Chrome, Google Chrome, can then be able to follow along as he is giving the practical session. Okay. Can I maybe just have someone who can just tell me what they think in their own words, what is a computer program or a software? Hopefully Elena, I would want to hear this from Elena.
What's answer? What's one?
Anyone, just in your own words, what do you think a computer program is or a software is, in your own words? It doesn't have to be perfect. We can always build on that. This is a safe environment. Hello? Anyone from maybe Mayara Combined School or Dr. Romanes or Okahanja High School? Anyone? Hello?
Step by step instruction.
Just in your own words, what do you think? What comes into your head when I tell you a computer program? What pops into your head first? Guys, are we going to be staying on this page forever? No one knows what a computer program is. Okay, maybe let me not put you too under too much pressure, but I would hope people to just say something. But to be a computer program is just something, it's generally instructions or something to tell a computer what to do. A computer in itself is a really dumb, powerful tool, right? It's generally, it can do a lot of things, it's very powerful, but it does exactly whatever you tell it to do. So if you tell it to do something wrong, it will do something wrong. If you tell it to do something right, it will do something right. I used to have a teacher who would tell me that rubbish in, rubbish out. So if you put rubbish into a computer, rubbish would come out. And essentially, a computer program is those instructions that you tell a computer what to do something. And we want computers to be doing some things for us. They are very good tools for us to use. They can do so many things for us. So we generally want to be able to tell them what to do. And that's where computer programming comes in. That's where we come in as software developers to be able to tell them or learn how to speak to them and tell them what to do. Okay, so programming itself, also called coding, is a process of now writing those instructions and testing and maintaining the source codes of computer programs. So basically, the process of writing those instructions is what we call programming. And we will speak a little bit more why you want to learn how to program, but some of the benefits are logic and problem solving skills. You would improve your attention to detail very, very much, because there is a huge difference between a capital A and a smaller a in a computer program, but it's really, really fun as well. Please do feel free to ask any questions as I go or we go through these presentations. It will benefit both I and you to do that. Okay. And right now, until recently, programming required computer language syntax. So generally, you would, as a programmer, most of the time, you would have to write code like this. A computer itself only understands zeros and ones. I don't know if at this point, the learners have learned about binary numbers, but a computer or a machine language only understands zeros and ones. So generally, the language that we write looks like this. But Scratch even makes it even better for us. It puts this language into blocks so that you don't even have to write this. But we will also go into a software called Blockly that changes the blocks to this type of code. And we have now converters in the computer itself that converts this language to zeros and ones so that the computer can understand. Okay. We did speak about giving instructions to a computer. To give instructions to a computer, you need to connect to it. It needs to understand you. So you need to speak the language that it speaks. So that's where we are now saying, as a programmer, you are basically learning the language of speaking to a computer. Okay. There are various examples of very popular programming languages: C++, Java, Python, and right now we are learning Scratch, and which is one of the basics programming languages and easy to learn languages. Almost everyone can learn them, from a child of even at a really, really young age can be able to learn Scratch. And Blockly is also a visual programming languages. There is now also PHP, JavaScript. There are quite a few of them, but these ones are the most popular. Okay. In terms of computational thinking, so computational thinking really is, it's just a way, because if you are speaking to a computer, you kind of need to learn to think like it, and computers generally think on a logical perspective. So computers, when they read instructions step by step. So they usually read them from top to bottom. Because they read them like that, and you are learning to connect to the computer, your thinking would also align to that. So it means you would now start thinking logically, and you start thinking in a structured way. And because you are trying to connect to something that doesn't generally speak or things like that, it helps you to learn to solve problems efficiently, logically, and creatively. So computer thinking in itself is just, it's a way of learning skills, of mainly logical skills and structured way of thinking skills. Okay, we can think about computational. Let me just move my block here. Okay, we can think about computational thinking in 4 parts. It can be compounded into decomposition, pattern recognition, abstraction, and algorithm design. So I will just go into each one of them. So decomposition itself is just breaking something into smaller parts. So there are some problems that are just easier if you break them into smaller parts, and then to solve the smaller parts to be able to solve a bigger part. And there is that, I don't know if people do know about that notion that says, for you to eat an elephant, you need to eat it small by small. Otherwise, you'll be just like, yo, that elephant is too big, I can't eat it. So it goes into the same way. So you'll find that when you are going to go into developing or coding, there are going to be some problems that are really, really big. So if maybe your mother asks you, can you please program program our pot so that it can cook the pap itself? You're just thinking, how am I supposed to go about that? But if you decompose it and you break it down into smaller things, you want to maybe deal with just the boiling water part, and then maybe you want to deal into the part where the flour needs to go in. Then you need to deal with. So if you break those things into smaller parts, then it becomes easier to be able to solve those small ones, and then eventually overall solve the bigger problem. The example they gave here is also like going to the grocery store. I think this one, it's just that most of us, we do it naturally. Like in your head, when a person says go to the shop, you already know that, okay, I need to decide which shop I'm going to go. I need to decide what I'm going to buy. I need to decide the time I'm going to go, and I need to decide how I'm going to get there. Will I get a cab or a taxi, or maybe my mom or my dad will take me, and I also need to know that I have enough money. Those things we usually calculate them automatically in our head because our brain has already, it does that at a very fast pace. But that's what your brain does. It breaks them, all those things down into smaller chunks, and then it's able to tell you, okay, yeah, go to the shop. Okay, feel free to ask at any point if you have any questions, okay? Okay. And then we go into pattern recognition. So pattern recognition just means sometimes if you recognize similar patterns, you are able to solve a problem faster. So if you are a soccer or a football fanatic like I am, there's always these opportunities to be able to predict whether which team would win against which team and how many goals the other team would score, etc. And some of these things you can really only work them out if you look at the statistics behind, and you look at how many times this team has played against another team, how many times has it won, and those things. Then you are able to make a more successful prediction. And in that way, you are able to solve a problem. So it's the same. So always learn to look at things that are similar, that are always occurring. In coding, that really helps you a lot to solve problems. Okay, then there's what we call abstraction. And abstraction really just says, forget about all the things that are unnecessary and focus on what is important. Here they said that an example is to draw a cat. If I say go and draw a cat, and you don't need to draw like a specific cat, how it really looks like. Please do bear with me. I just need to deal with my background. Okay, apologies, I'm back again. So in this case of drawing a cat, it's basically just saying that if I said draw a cat, for me to recognize that it's a cat, you just need a few things. We need to have maybe a tail, a long tail that's circling. We need to have fur, the hair that's all coming out, and then the eyes. If you draw something with these things, everyone will know that you draw a cat. And that sometimes that's how you solve certain problems. There are some problems that you don't need to know all the little other details. You just need to focus on the details that are important. Okay. Then algorithm design. So in coding, the last thing that you do is algorithm design, and which just means now you create those step-by-step instructions that a computer will eventually read. And the best example to do that is when you are giving directions to someone. So if you are giving directions to someone, you always need to tell them, no, go to this street, 10 left, and then after that, move maybe 100 meters. So you give them specific instructions. And the computer is like that. You need to tell it exactly what to do. Step one, you can't leave out the little steps, because the moment you leave something out, it will assume something else and do something maybe that you did not want it to do. So algorithm design is just to be able to create those step-by-step, simple step-by-step instructions that it can follow. Okay, and we did talk a little bit about digital skills, And in terms of the benefits of them, if once you are learning digital skills, it will really build your confidence. It's very fun and interactive. It helps you develop your computational thinking. So that is like analytical skills. You are able to now start analyzing problems. You are able to solve them, and you are able to have logical thinking. And it really has future opportunities. There is such a high demand for computational skills globally. So there's always software developers currently that are needed to develop certain solutions, especially right now in COVID-19. It would have been nice if we have Namibian software developers solving all these problems that we have at a digital level. And then it's it's a competitive advantage. If you look around you, there's so many digital equipment or things that are around you, from a microwave to a TV, to a remote, to gaming devices, to almost anything that has software in it, to a phone, to radios. All those things around us are digital. So you'll be able to understand those things more and be able to use them better if you have digital skills. Yeah. Okay, and just if you are very popular with, if you know Facebook, Mark Zuckerberg is the founder of Facebook, and he says he's always advising friends that everyone should learn how to program. And then Steve Jobs, he thinks it teaches you how to think. Steve Jobs is the founders of Apple, all the Apple iPhones, etc., that we all love. And Bill Gates is all Microsoft and Windows. He says it stretches your mind. Okay, so these are just some of the few sayings of people that have really engaged in the technology world. Yes. Okay, and coding is also a close curricular subject, meaning that if you learn how to code, it will also help you with all your other subjects that you are learning. So chemistry, mathematics, technology, biology, physics. Just imagine where you can, I mean, right now on the internet, you can essentially draw all the atoms and stuff like that using a computer online. So you are able to draw these atoms and draw the formulas, etc., online if you wanted to. Languages, you are able to learn various languages just using a phone application. So all those things, you are able to bring technology and your coding skills into them. Okay. Okay, and we also just want to emphasize that anyone can program. Anyone, I mean anyone. It just depends on your willingness and your passion for wanting to learn. And programs like Scratch really help you with that, because they are very, very easy and they are visual. So you don't need to start with a complicated writing lines of code. You can start with Scratch, which is quite easy. And Scratch is just a powerful program that was created by MIT Media Labs. This is an American institute, technology of, generally they just do engineering subjects. And it's a visual coding program. So this is the one that John is gonna get us into. Okay, and just before we get John on the platform so that he takes us through the practice session, this is what I was explaining to Dr. Romanis, and that is, let me just get my my Windows. So you can go to Scratch in two ways. So you can be able to go to Scratch online and be able to code it from there, or if you already have it installed on your computer, like I do, then you can also just be able to view it on your computer offline. But for you to be able to view it on your computer offline, you do have to download it. So if the computers don't already have it downloaded, but they have access to the internet, Dr. Romanis, the kids, they can download it now. If not, they can just follow along and then be able to maybe download it later. But this is the offline version one, the one that I have on my computer that I've already installed. And it's exactly the same as the online version one. Yeah. So they're exactly the same. It's just, you know, my internet is a bit slow. Let me see. Okay. So This one is the offline version. This is the one that's the offline version, the one that you install. And then if you go to, let's go to the internet, and then maybe go to Scratch download. Then if you just go to scratch.mit.edu/download, or you just Google Scratch download, it will be able to get you to this site where you are able to download it onto your computer and be able to use Scratch even when you don't have access to the internet. Okay, but they are exactly the same. It's just that my internet is loading slow, so I will leave it up to that. Okay, is everyone still with me? Hello, John, can you hear me?
Yes, yes, we are around.
Okay,
We are still here. We are still here.
Okay.
We are here.
Okay, I'm hearing something. That's great. That's great. Okay, I'm just gonna hand over to John. I'm gonna hand the screen over to John, and he will be able to take us through the practice session. If you have Scratch open on your computer as a learner, feel free to follow along as to what he's doing. Okay. John, the screen is yours.
Thank you. Yes, good morning. Good morning, everyone. My name is J.N. Amutenya, but as my colleagues say, you can call me John. I'm going to take you through the practicals of how to use Scratch. It's very easy, very interactive, and very fun to use. Are we all having our Scratch open?
No, Elena, they do not have for now, unless they need to download it again.
Okay, if you didn't manage to download it, I have put a link there, or if you check the messages there's a link that I put for you to be able just to, if you click on that link, it will take you directly to this page which I'm on right now. What you are seeing is what you're gonna get when you click on that link. Then you'll get this so that they can be able to follow those who are having, or those who are in access of laptops.
Where is the link?
Internet on.
Are
we all there?
No.
At the messages.
Yeah, which side is that?
If you check on your panel,
We got
you find
that one.
You got them
On the chat.
Come again?
Is it on the chat?
Yes, it's
yes,
on the chat.
chat. Yes, on the chat, I put a link there.
I'm not seeing that now.
Just click on that link and it will bring you directly to this page. For me, I'm going to use the online one, not the downloaded one, but they're all the same. They work the same. Either you're working offline or online, they are all the same. May I start? Are we all there for now?
Yes, yes, boss, we are on.
Okay, thank you very much. Now, this is the interface of Scratch. There's so many blocks here. If you look at this side, on the left side, here, where my pointer is, it has 3 tabs. The first tab is code. Second tab is backdrops. Third tab is for sound. Now, we are going to dive in and just create something basic. I prepared 2 things, basic, just a basic animation, and one advanced game that's going to be fun to create. What we need is, if you come here, it's where you can choose your sprite. In other words, so you can choose your avatar, what you want to use when you're creating your when you're creating your game. So let's say we come here, we click there, you'll find a lot of options. It can either be animals, people, fantasy, anything that you need there, it's there. They are already provided for you. I'll choose animal. Let's take cat, for instance. If you click on it, it will come up. As you can see now, it's here and there. This one, you can just move it a little bit where you want it to be visible. So, before, as my colleague used to say, a computer is an amazing tool, but it cannot do anything on its own. I can say a computer is dumb because we are the one that feeds it. We are the brain. We are the one giving it, only that we do not have the power to process faster like the computer can. So it makes it easier for us to process things very faster. So we give set of instructions to the computer in order for it to execute it for us. This set of blocks, as you can see here, those are set of instructions. So this panel here, from this corner to this corner here, it's where we are going to set our instructions. Let's say this is our playground here. It's where we are setting the instruction for this sprite to be able to execute or to do what we are telling it to do. So before anything, you want to start, how do you want to start? If you see this green flag here, it will say go or start. I want it to start there. If I press on that, if I click on that green flag, it must be able to start. This red one here is to stop. Let's say I was busy, I said, I used the flag, and then I was like, okay, let me stop. I made a mistake. I need to change something. You just come here to stop so that you can end whatever it was doing. We have multiple tabs under code. We have motion. We have looks on the left side here. Looks, sound, events, control, sensing, operators, and variables, and my blocks. My blocks is just, if you are good at it and then you create your own blocks, you put it in there. So that next time when you do, you just go straight to there and then you get what you want it to be done. As my colleagues say, abstraction. So you don't want to go through the whole process of clicking one by one. If you know what you want, you just put it in my blocks, you save it there, so that at least once you drop it here, it starts dropping everything that you need to do. Now, let's start with the event. When do you want this sprite to move or to do anything? Let's use when we click on the green flag. Meaning if we click here, this will start doing whatever we are told, whatever block of code we put here. These are the block of code here that we are telling this sprite to do. Now, let's say we want this cat, this sprite, to say, hello, my name is John. So we just come to motion here. Let's go here. Looks. We go in looks, and then we say, what are we telling it to do? We say, it must say, hello, my name is John. So we do this, we drag, you take your pointer, this is your pointer, you bring it here, click on the left side of your touchpad, and then drag it. You just drag it here. As you can see, it's already made to fit here, there. And then we change what it is there, and then we just say, hello, my name is John. There. Now, if we click here, what do you think will happen? This will pop up here for only 2 seconds, since I said 2 seconds here. This is the time limit that you are saying it must be there. You can change this for how long you want it to be there. Now let's click here. Hello, my name is John. Only for 2 seconds. Very simple there. Now, we want it to do more. Let's say we want it to walk. So we go to motion. We tell it, you know what? I want you to move 10 steps. If I click here, it will move. That you saw the movement, but it was too fast. So we want it to move towards here. So we tell it, you know what? Keep moving. Let's say we want it to keep moving for good, or maybe for a specific time. Let's say we say move for 10 seconds. We can repeat that movement for a specific time, depending on how long you want it to keep doing the same thing. If you click there, it will move 10 steps like that. Now, if you want to take something out here, let's say you don't want it to repeat like that, only drag it, and then you just drop it back there. Nothing will happen, it's just removing it. So we want it to keep doing that for a very long time. There. As you can see, I'm putting this inside here. This is called a loop, a repetition. In other words, you can say it's a repetition. It will keep doing whatever it's inside here forever. Because that is what you are telling that do it forever. It will keep doing that. Let's try. Now we have a problem. You see that it went on the other side, it reaches the edge. But that's not what we want it to do. We want it to keep moving here like this, like this, like this. What you can do is, you just stop the program here, you stop it, and then you say, okay, we want, once you reach the end, you should be able to turn back again, and then you back again. So what we do is, we come to motion again, no sensing, we come to sensing. Sensing, motion. Once you reach the end, it's in motion. Once you reach the end or the edge, just bounce back. Once you reach there, just bounce back. So let's try. Okay, let me stop it. Let me just bring it back here. You see, it keep doing that now because you keep telling it, do it over and over and over and over and over forever. Now let's stop it here. This is very weird. Imagine you find a cat walking upside down to freak someone out. Now, what you're gonna do is, we're gonna change how this cat looks so that it walks normal it's supposed to walk. So what you're going to do is, you see this here in motion, set rotation style, left to right. That way, when it comes here, it will move back as it's supposed to. So let's try it. Now it's moving in a direction that you want it to be. That's how it's supposed to move. It's a very simple thing. Now, if you come here, you see there's a panel there which is written, choose a backdrop. Choose a backdrop. That means you are choosing the background of this. In what background do you want it to be? Here, you say, this tab here says choose a background. This one, you want to paint it, you can paint yourself. Here, it's a surprise. If you click here, anything can come up because it's a surprise. Here, you can upload your own from your computer, or you download something from the internet that you want, or you can even put your own picture from your computer. You just click there, and then it will take you to your computer. You see, it opens here for you to choose whatever you want from your computer. You can choose anything that you want from your computer, wherever. You just navigate to go where you want. If it's in pictures or in downloads, you just go there and then you click it, and then that's what will happen. Let's say I want to take this one here, and I just say open. Sorry, it's a little bit slow. Just bear with me. You see, there it is. I put it there, it's there. Now, let's say you want to modify something. You can just come here. It's written backdrops. You can come here, paint. You can fill. Let's say you want to fill with a different color. You choose whatever color you want. So you can start doing whatever you want with it. On this one, let's say you want to make this green here. You just keep doing that and it will come up like that. It's green like that. Or you can take the brush itself. Or you can take the brush itself here and then you can just do it here. My computer is a bit slow. All right. Let's go back to our main backdrop here. Now, let's choose whatever is already there for us. We go to choose backdrop. You find other tabs here, as you can see. What type of backdrop do you want? Do you want the cat to be underwater, in space, indoors? So you choose on your own. So let's say if most of you watch Garfield, it's a very funny animation. So let's put the cat in a castle. We put the cat in a castle. Now you see, now here it's like, hey, this is not good. See, the cat is flying. We're supposed not to do. You just drop it down to where you want it to be. These are coordinates here. We have the X vector and the Y vector. So you can, if you move around with this, you can see that the X and the Y vectors are moving, they are actually changing. You see, if you move it this side, you can see. You can change this to whatever vector you want. At the same time, as you can see, the cat is a bit too big. So you come just to size here, at the size. And then you just, let's make it 50%. Make it 50. There. Now the cat is on that one. We change the size of it. Now, the direction, how do you want the cat to be walking? Do you want it to be walking like this, or like this, or like that? It depends on the direction that you are giving it. Which direction do you want to go? Let me put it here so that you can be able to see what I'm saying. You can put it, if you click here, the compass will come up for you. If you move it up, the cat will be moving up. Let's see. Let's go to code. And then we just do that. Then you play and see how it's moving. You see, it's moving 40 degrees up. But why do you think it's bouncing around like that? Can anybody mute and just answer that? Why do you think it's not going in a straight line? Because it's supposed to be going straight like this. Can anybody be able to answer, students? Anybody there? Hello? Are we here? Or am I here talking to myself?
No, we are here.
Yes. Why do you think this cat, instead of moving straight like the way it was, it's now bouncing around the whole place? Like that.
The direction was changed.
Come again?
The direction was changed.
The direction was changed. Yes, the direction was changed. Now, once it reaches the corner here, instead of going 90 degrees back, it's going up like that. It's taking the 40 degrees. That's why it keeps bouncing around, because of this, also this here, this instruction here, that once you reach the edge, bounce back. So it's bouncing back in a 40 degrees. Now let's put back to 90 degrees so that it can go the same way it's supposed to go. You can just do that, or you can put the number themselves. You can just type in the number. All right. I didn't come to costumes yet. This is just a basic coding. We are coming to the advanced one. where I'm going to create a small game for you. So we can explore all other options. There are so many options here that you can explore. But as they say, practice makes perfect. You can practice this on your own and try other tabs. You look at it, and then once you click, and then you say, what is it doing? But I'm coming to the advanced part, whereby I'll create a game for you that you see that I'm going to use most of these here. Now, let me teach you the basic also here. We go to costumes. Now, every sprite comes with its costumes, or you can even create your own. Now, let's do this. If you do this, you can see that now the cat is moving differently. It was like this, like this. Now, this will be more realistic to a game or to your animation. Now, imagine the whole way the cat is just like that. It's just moving like that. So at least it must be moving, because when you are moving, 1 foot in front, 1 foot behind, 1 foot in front, like that. That's how it's supposed to be moving. So here, you can tell it, use next costume. See, now it's moving. You see? It's stepping. It's not only in one position, but it's stepping, going forward, going forward, going forward. But if you say, let's say you want it to be moving from here to here, you want it to move in this costume, and you want it to be moved in that costume. So we come to costumes. Let's come to costume. And you want to paint this guy here, so that when it moves, I want to see the difference, that when it moves, it's moving. So I can choose any color here. Let's take my favorite color, blue. I love blue. Let's darken that blue. You see these controls when I'm moving them. You see, let's say let's do this. You can see that it's that blue and that blue, but I want the darkened one. All you have to do is just to do this. You change the color according to how you want it. You want black, you want it a bit light blue. If you want it light blue, you just change here a bit. It comes to going to green, but let's take blue. You see, once you bring your pointer here, you can see that it's changing something. It's making it blue where you want it. So let's say I want only the leg behind here is the one to be blue, and this one here, like that. And here, I want it something else. Let's say I want the beards to be black. I want the cat to have black beards. There. Now, if I play here, or I click here, you can see that the color is changing once it uses the other costume. It's changing. Now, let's end there. I'm going to teach you or train you on the third tab, which is sounds. So the cat makes meow, right? So we can play the sound like meow. So we come here, we go to the sound one, and then we play meow before it can say my name is John. There. And then it will say. Now, you can create your own sound. We stop this, and then you can create your own sound. Maybe you don't want it to say meow, right? So what you do is, you come here, there's a drop down here. You can see that there's an arrow pointing down, and then you just record. Once you go and record, this comes up, and then you just press the button and then say what you want. If I click here, then I say meow. That sound, I save it, or you can play to see how it's sounding. Meow. Now I think like I said, ni hao in Chinese. Okay, you bring it up. You can change the title here, that maybe my voice. And then you come back to code. You change here to my voice because that's the sound you wanted to use. And then you click here and then you listen. You see? It's very simple. This is just the basic of it. I believe I have touched the code, the costumes, and the sound, but I forgot to touch something. How do you save this? Where do you want it to be? Because now I'm done with what I want to do. Now what do I do? Do I just close and go and find it tomorrow when I come back on? So you just come to file here, and then you tell it to save to your computer. And then you choose your location where you want it to be saved. Or let's say now next time when you come, you want to open what you have already started. Let's say you were busy creating your animation or creating your game, but you have to go do something else. You just save it. Save it here. You just come and then you save it. The next time when you come, you just come here again and then you just say load from your computer. And then you find what you saved, that animation or that game you were busy coding, you just go and find it in your computer and then you click it and then you open and you continue from where you left off. Now, let's go back. Let's try something else. Let's say now, you know, I was having enjoying this and I was like, I don't want this anymore. I want to try something else. You know, I want to delete this whole thing. If you just come here, you can see there's a bin here. This bin here. You just click on it and it's gone. But why is it still here? Because this is here. You come here and you can change it to whatever you want. Now, let's go back and then check what we have here. Then you can change it here. This one here, you can change to whatever YX grid you want it. Let's say you want it to move in this direction or that direction. If you press here, it will give you that, the option of saying, I want it this direction, like that. Let's say you're creating maybe a graph or something. This is where you get it. So let's see, let's do this. Let's get a new one. Create a new project. Take this cat away. That's a delete button for the cat. Now I'm going to create something, or let's say a small just game. I know after I'm done with this one, you will feel like, yes, you are very good at Scratch already. If you are following, are we all following there? Are we following, students?
Yes, they are following.
Very good. If you are having Scratch open, you can follow with what I'm going to do now. I'm going to create a game whereby you are going to use arrows and other things for you to move that game. I don't know whether any of you have played Snake on those long time, the Tamagotchis, they call it Tamagotchis, the Snake on the Tamagotchi. It's more like that one. Yes, it's more like that one. Very simple, nice one. Okay. Now, we're going to choose, please, if I'm going too fast, please do say something. Say something so I can be able to know that I'm going too fast so that I can slow down. And if you have a question, please feel free to just unmute yourself and then say something and say, you are going too fast, or I have a question on this and that. And then we'll take it from there. Right. Now, let's choose our sprite or avatar. We're going to choose, I'm going to train you on how to use more than one avatar in one game. I mean, in the animation, not just to use one, but to use a couple. Let's take the crab. You know, when you're creating, when you're programming or when you're coding, very easier for you to familiarize yourself with what you are doing. So as you can see here where it's written sprite, you can change the name to something that you feel like yes, something that I am okay with. If I see it, I know what it is. So for me, I'll name it Krabby because it's having those hooks to grab, you know. I name it that. So I need to have two sprite here. I'll change its size. Let's make it 50%, like that. I'm going to add another sprite. Let me see. I'm going to choose a parrot. Now we have these two. We are going to use this again. That every single time this parrot moves around and touches this, then it's game over. For the user who is going to be playing this game, this is going to be controlled by the computer itself. This will be the snake in that Kagamagotchi snake game. And this one will be like a dot that is moving around, escaping this. Now, let's start with this. In order for you to navigate around, to know which sprite are you coding for. You can see here in the corner here, in the top corner, you can be able to see that you are coding for the parrot. But, and also here down here, it will be highlighted blue. Now, if I click here, you can see that it's changing here. That means I'm now coding for this, for Greppi. Greppi here is the one that I'm checking for. I want this Greppi that every single time when the parrot is flying around, I want to be the one navigating it to escape being touched or by being eaten by this. So what I can do is we come to our codes. We come to our codes that as always, you can choose either when you press any key or when you press anything. You can choose on your own what you want. Don't feel like you are restricted only to use the green here. You can choose here that I want it when I click what. Yeah, there are so many options. If you check on the drop down here, you can say if I press the arrow, the up arrow, I want it to for the game to start. Or when I press the space button, then the game should start. Or if I press any of these alphabets here or these numbers here, then the game should start. But for me, I'll choose this one for now. When you press the green button. Now, I want this to be moving as long as on a condition that this parrot did not touch me. So I can keep moving. If the parrot touches me, then game over for me. So as long as I'm moving, but this guy does not touch me, I can keep moving over and over as I want. Therefore, I'm going to control here so that I can control my movement. We are going to say repeat. I keep repeating over and over and over. As long as, what is the condition here? Because you are saying repeat until, asking you only when should you stop? Because it's asking repeat until. These are called conditional statements in programming. It's giving you a condition that you can keep doing this until this happens. It's like I give you food. I say, keep eating until you are full, or keep eating until the food is finished. I'm giving you the condition that that's what you should do until that specific condition is met. If that condition is not met, you will keep doing that until that condition is met. It's conditional statements. Now, what are we saying here? We want you to keep moving around. We want you to keep moving around until something is done. What is that we want you to do? Until this guy touches you. Now, until you touch parrot there. And then I just bring it here. See where I'm placing it. See where I'm placing it. Because this is a condition that is on top here. You see, it's even fitting. Once you see, it's already activating that, yes, it fits here. Let's say I decided, no, I don't want to put it here. I want to put it down here. You can see that when you are putting it down here, there's nothing that is fitting. If I try to put it inside here, it's not fitting at all. This is like a cardboard or a game board that you put, it must fit each other there. So we see it fits perfectly fine. You are saying, repeat until the parrot touches you. Now, what you need to do now? I'm going to tell, because we say we want this guy not to be moving by himself. We want us to be the one moving this guy here with the arrows. So I'm going to put up a couple of if statements. I'm going to put up a couple of if statements. If, which is inside here, because it's still under the repetitions, that you will keep doing that. If I put this outside here, this will execute only this. As we say, this algorithm goes, the computer executes one by one, sentence by sentence, sentence by sentence, unless it finds another condition that tells it, no, if you come here, and this is what it is, please proceed. It's like you are going home, you reach the door, and it tells you, if the door is open, just proceed. But if the door is locked, grab your key and open and enter the house. So as long as there is no condition that tells you to do otherwise, then you keep doing that. Therefore, I'm putting this within here. Now, if I do what? If I press the right arrow here, you see, it's already activating that it fits there. If I press the right arrow, which direction should I go? My people, which direction, if I press the right arrow, should I go up or should I go down or left or right? Meaning we should go right. We want to go right. So we say, once you press that, we have to set now the direction. We are pointing the direction that we are going right. So if we know that if you go here, if you know our direction very well, if you know our compass, this is the circle, our degrees. This is 0, and this is 180 straight here. So we are going which direction? Which angle is that? We are going 90 degrees. So we come here, and then we choose the motion of our motion here. You go to motion. Point in what direction do you want it to go? What direction do you want it to go? If I come here and choose, let's say I choose 120. Look what happens. Oh, I didn't set the motion. So I only told you that you are going there. See, computer is something that whatever you give it, it's what it takes. I didn't tell it to move anything. I just say, we are going to keep repeating this until when I press this, go this way. But I didn't tell it that it must take steps. So I come here, I tell it, just move 10 steps. in that specific direction that I give you. Move those steps. Now, if we play here, or we click here, and then I press my key, you see it's moving 120 because I told it move. Press the right the right arrow, move 120 degrees and steps 10 steps. Every time when I click the right arrow, moving those steps. Now, but that's not what we want. We want it to move 90 degrees so that it can move in the right direction that we want it to be. Now, if I click here and then I use this, it will move in that direction. We are going to do this for all the arrows because we are having the up, down. We are going to put all this one here. But be very careful when you are putting that. If now I put this under here, see where I'm putting it? Under here, then it will keep executing here because it's under. So each if should be under indentations here. It should be under the repeat until. So you see, this is a block for the repeat until. This one here, it comes like this, like this, like this, like this. It must be under that repetition. That's what you are doing. Because now if I put it here, it will be only working for this here because this is of the right arrow here. So it will not do what it is supposed to do. So every time when you are coding something, make sure that you are coding it and you are seeing where you are putting it. If you put it at the wrong place and then it will not execute as it's supposed to do, it might give you something else. So we are going to take the down arrow and then we just bring this one here. We tell it still. We want it to move 10 steps. Still here, you can see it's fitting. We want it to move 10 steps. But in what direction do you want it to go? Are we going in the 90 direction again? Are we there? Should we take the 90 direction again? Now we are going down like this. Let's say we are going like this. We are going down here. What angle is that? Is it 90 degrees? 60 degrees? So you come here, just click here, and then it will already point to you that we want it to go down here. We bring it here. If you know your angles very well, you already know that going for 180, you just click here, then you say 180. Or you can just click here and then you can move it with the arrow so that you can be sure of if you are not 100% sure if you're supposed to go that way. So we come back to control. Let me put all this because we need 4 of them. Put 1 here again. I put 1 here again. There are 4 like that. So we go back to sensing. We take now here. We already done the right. We already done the down. So we must do the left. So we choose the left here. Choose left here. Then we drag this one and bring it here. Same procedure. We still have to point the direction and we still have to move. So we come here. And then we say, okay, we want to go which direction? We bring it here. Which direction were you supposed to go this time around? If you know, you can just input the number yourself. If you do not know, you can just click there and then you move it. Which direction you want? We are going to the left. There. Negative 90 degrees because that's where we are going. Now, the reverse of that. What are we saying? We didn't tell it anything. If you come to this point and then you click the left arrow, nothing will happen. Why? Anybody tell me why? Students? Anybody tell me why you can't do anything there? If you click the left arrow, nothing will happen. Why is that? You can just unmute and then say something. That way I'll know that you guys are also there listening to what I'm saying. And I'm not just preaching to myself in my computer. Anyone?
You're not answering. It's unmuted.
Anyone there?
Answer. You're saying if you can repeat the question.
Come again.
Can you repeat the question?
The question is, if you check at this line of block here, these codes here, we say if I press the left arrow, you must move in negative 90 degrees. But now if I come here and then I do this, this is going because I'm pressing the right arrow. This is moving because I'm pressing the down arrow. Now I'm pressing the left arrow, but nothing is happening. Why? Look at this code here.
Oh.
I keep pressing the left, but it's not moving. Why?
No instruction first.
Yes, the instruction just ends there. I did not further say do what next. But as you can see the rest of the instructions here, it says move 10 steps. But here I did not put move 10 steps. So it's not gonna move because I did not instruct it to do that. So everything that this Mr. Krebi is going to do, only what you tell it to do. If you do not give it instructions, it will not move. So therefore, we are going to do this and then say, okay, you know what? Let's move 10 steps. If I now press left arrow, you can see down it's moving. If I press the up, it's not moving because it's nothing is defined or nothing is given for the up arrow. We do not have the up arrow yet. So what we are going to do now is that we're just going to put up, we're going to the sensors and then we choose the up arrow and then we bring it here. We point in the direction that we want it to go back in motions because as we're setting the motion. Let's say we want it to move still 10 steps the same way, but in what direction are we putting it? What direction are we supposed to go this time around? Because we are going up. So up is where? Up is here. We are going in the ankle. Now, if I click here to play, you can see that I can move up, left, down, up, right. It can move around. Now I can be able to navigate around. Now I'm moving around, no problem. Now I'm fine to move around. Right. Are we done for this? For now, I'll say I'm done with it for now. I'll come and continue once I have set for this guy here, Parrot. Now, Mr. Parrot, again, you can see that I'm now coding for Mr. Parrot here because he's the one that's in the corner here. I'm saying, you know what? Because this guy, I'm not the one who's going to be moving him around. I just want him to be automatic, that he's just moving, bouncing around the whole place. What I'm gonna do is, because this is a game, we are doing a game, so you need to have scores, right? You need to have scores. I want to know that I scored how much in this aspect. Now, what you're gonna do is, I'm going to create a variable. Variables are called, these are just placeholders. These are just placeholders to hold something for you. Let's create one. In this case, we are creating score. So meaning every time when I get a score, it will go in that placeholder called this variable. We are going to make it score. Like that. You see? It's there. Why do you think it's writing 0? Because it's going to default. By default, it's 0. By default, it always goes to 0. Now, let's do the coding for this guy now here for him to be moving around as much as we want him. So we're saying the event, we want it to start once we click the green button. I mean the green flag. Once we click that flag, I want this game to start moving. Now, I want this guy to be turning. I can choose either degree. I want him to go like this, or I want him just to go like this, like that only. It's up to me to decide. This one is made possible by this guy here. Turn, which side should I turn? Am I going clockwise or am I going anti-clockwise? As it shows here, in which degrees you are going. If I decided that I'm going to take this and put it here, let me say I'll take 30 degrees. Meaning this guy will start moving in 30 degrees. But now, even if I click on the green flag, nothing will happen. Why? Because I did not tell you, okay, it will move in 30 degrees, it will move in 30 degrees, just at the same position. It's not going anywhere. It will just move in that 30 degrees, but it's not going anywhere. It's just at the same place, not moving anywhere, because I want it to move around the whole place, searching for this guy. But if I did not tell it that move around, I just tell it to be moving 30 degrees, to just be moving at that specific point. Now, I want to go to scores that, because it's only one pair at the moment, I just want it to be, I want to set my goals. I just want to set my variables here, that because it's one parrot, my variable should be just one. Because if there's one here, just want it to read, right? That's your score. Your scores is counted according to how many parrots are going to be here in this area here. This parrot is going to do something else. The more the parrots become a lot, the more your scores goes up. So that's what we are doing. Now, what do we want this to do? We want this guy to be, to be moving around the whole place. So let's say we set the motion, we tell it, you know what? Let's make it an infinite one. Keep moving forever. Keep moving forever. But you remember that when Mr. Krebi, I told Mr. Krebi there that there's a condition that if that happens, end the game. Now, we're saying, keep moving. I just want you to keep moving. So I told it, the motion, we set up the motion. We tell it to move. Keep moving as many steps as you want. Now, if you play, you see it gone. I know you remember something which I was doing that time when the Mr. Ketty was coming here and never comes back. You know what that is? Anyone can tell me. There's one thing that you need to put so that when something hits on the edges here, it must come back. What one? Which one is that one? I know you all remember that one.
It should bounce back.
Yes, to bounce back. So we tell it to bounce back. We tell it, you know what? Once you reach there, bounce back. I want you back. So we tell it like that. You see? It's now bouncing all over the place. Why do you think that it's moving, but nothing is happening here? It's touching the Mr. Krebi there, but nothing is happening. It's because I did not define any here again, that when Mr. Parrot touches this is what happens next. I didn't tell him to do that. I only told this guy that when this guy touches you, then this is what will happen. But I did not set it up yet. So I need to code for this guy also. All right. Now, we leave that one for now like that. So what you want here is that after specific, but he's going too fast. Let me change his steps. Just maybe 5 here, because he's going too fast, so that you don't just lose the game in 1 second. You already lost. So that would be not fair. Imagine you are paying $1 for you to play this game, and every time when this guy is going too fast, I'll want my $1 back. We can make it 3. Yes, that's by much better motion. All right. Now, let's give more instruction to Mr. Parrot. Now, I'm done with this one for now, but you can have multiple here. You can have a lot of this coding here for the Mr. Parrot room. So let's do this. Same thing, once the event is started by this. So what I want now is that I want every time after a few minutes or few seconds, I want this guy to clone himself, to duplicate himself, so that it becomes a bit difficult for Mr. Krebi to be maneuvering around him. Because if it's only him around, I can maneuver the whole day. And that will not be good. It will not be a good game, because you have to think realistically that a game should be able to end at one point. You cannot just be playing the game the whole day and there's no losing. A good game is when people are losing also at one point and win at some point. So now we wanted to make it difficult for this Mr. Krebi, that these guys will become a lot. It's going to be difficult for him to be maneuvering around him. We are saying we want this guy to keep moving forever. And then in that time, I want to create a clone of myself. Who is myself at this point? When I'm saying I want to create, I'm not going to make another Mr. John on the other side. So who are we creating here? We're creating who? Who are we cloning? Yeah? Who are we cloning? Yes, we are cloning this guy here, Mr. Parrot, so that he become a lot. Create clone of myself. Myself, meaning I'm speaking on behalf of this here, because I'm in his tab, I'm in his playground. This is a playground for Mr. Parrot here. But I decided, no, once I create one, I want my score to be up, because what's the point of playing a game if I'm not winning anything? So every time this goes up or they become more, those are my scores. That means I won that. I have those ones. Therefore, here I'm going to say, I go to variables again, because I want my variables to go up by 1, so that once it goes, it becomes, it goes up by 1. That is done for now for me. And I say, but I didn't set it. How long or after how many seconds should I be able to clone myself? Because if I do that, you see, do you know why that is happening? It's because it keeps cloning me over and over and over and over without me specifying what time. And those are infinite ones. Oh yes. My laptop decided to freeze. Because I gave it an infinite one. Are we there?
Yes, we can hear you, John.
Yes. All right. Do you know why that happened? Do you know why my laptop decided to freeze? Because I gave it an infinite loop. Now, this Mr. Parrot being cloned over and over and over to the point that the computer can no longer take it, because I did not set that it must do after how many times, how many seconds. So I'm going to set it that in control here, wait until before you clone me, wait for at least 5 seconds before you can clone me. Let's see. After 5 seconds, it clones. But once it clones, you can see that the clones are just there. They are not moving because the only instruction I gave at the moment, I only gave it to this guy, not to the clones. So there's something that we need to do about that. So we say, when I start as a clone, because I'm giving that instruction now to the clone, I want you, Mr. Clone, to move, not to move yet. I want you to, I want you to turn 30 degrees also, depending on you in what degree you want it to go. I can opt to choose something else, which I'll come and show you if we have the time. Move 30 degrees, and then, because we want you to keep moving forever, we move forever. What code is the same exact code here? The down one here is the one that I need to put here because I want it to do the same thing here as Mr. Parrot, the original. So it's what I want it to keep doing. So we say move 3 steps. If you reach the edge, Mr. Parrot, if you reach the edge, please just bounce 30 degrees back. There. Now it's doing what we want it to do. So let's stop there. Now we go back to Mr. Parrot, to Mr. Grabby. When you want to navigate around, you just come here, you go to Mr. Grabby again. This time around, we want to change that once the game starts, I want it to have this background, the white background that is already there. So I just come here, I say, switch background to that white one. But once the game is over, I want to choose another background, or when the game starts, I want you to start something else. So where can the parrot and the crab be? They're always at the beach, eh? Somewhere there at the beach. Nah, too dark. Or maybe in the forest. You can choose where you want it to be because there's so many places that you can choose on your own here. You just navigate around and then see which one you want it to be. You want it to be here. Now, when you're choosing the background, you should also put in consideration about these guys here, their colors, because otherwise you'll have the wrong color that side. Now we say, I want to change this background once the game starts. This one comes here because it's once the game is done. Just hold on. I'll put this guy here. Let me isolate that. this one comes here, it's in the woods. We say come here once the game starts. And switch to background 1 once the game ends. Now, when we play this, what is that? Where did I put it? Oh, it didn't move. No wonder. Okay, let me drop this one here for now. Go down. We're all following, right? We put him here. Then once you reach there, that's what I want you to be. That now, how do I know that the game is over? I just put up something like, say, game over. And then everything that has been started should have an end. So we say stop all when you reach there. But if you have seen that the scores was remaining the same, so that means something is not right there. So let's go back to Mr. Parrot and find out. Here, we just have to change here to score because I named my variable score and I forgot to change it. That it's score, it's not my variable, but it's score. Now, if we play again, we go back to the main character here, and then we play. We go back to the main character here, it's playing. You can see that we are only having 1. Since the parrot became 2, I'm having now 2. They became 3, I have now 3. Because I'm scoring, and game over for me. This is just some few lines of code that you can use to make your own game. Very easy to use. You can add sound here. While it's playing, while it's busy playing, you can put a sound that it must be making any sound that you want. You can say play sound until done. Let me put this here. Let me put it here. I'll put this one here, then make sure that it's also attached this one here. And then I'll record my own here. You know how to record most, right? I'll record my own. That says, game over. You see, now, because I want it, when I'm done, I didn't name it, I just put it recording. So it's recording 1. Once I get touched, because I got touched, now it will tell me game over for you. So this is just some few codes that you can run to make your own game with these codes here. You can see that all these codes are already done for you. For you, it's just to come here and choose what you really want and where do you want to put it. Are we having questions so far? Are we there? Any questions?
We are here.
Yes. Any questions? What if I decide to put this here? What if I decide to put this one somewhere here? What will happen? Will it change the costume? I told you which one is the costume. Mr. Perot has how many costumes? 2 costumes. Will it change the code? Every time when Mr. Perot move, make a clone, it will be in a different way. It's all about playing around with the code and knowing where to place it. Students, are we there? So far, I've been just hearing the say, but not student talking. Students? Students?
Yes, sir. We are here.
Are we all fine?
We are okay.
If anybody of them tried what I was doing, was I too fast? Now, time for questions.
No questions, sir.
Any questions? Students? Please, I need questions. I'm hearing someone in the background there. You want to say something?
Yes. What is the case? You're not saying my name is John.
Louis?
Yes, I think he's saying, what if the kid does not say my name is John? Did I get that question correctly?
Yes.
What if the kid does not say?
My name is John.
I can't really hear them. They're way too far.
Oh yeah, he's saying, what if the cat, because remember when you started at the beginning, the cat was saying my name is John. So what if the cat is not saying that, maybe saying something else?
As we already said, that the computer only takes what you tell it to do. If now you told it, let's say you just grab this the way it is, that cat will just say hello for 2 seconds because this is what you gave it. But if you tell it, if you say, look at this line of code here on my Mr. Grabby here, you all did not see that these words here, game over, right? Did you see it? Did you say this game written game over? No? The reason why is because I only told it to say game over, but I don't tell it to be there for how many seconds. So if I put it back here and then say, and then that, and it's writing for you game over, because I told you to say game over for 2 seconds. If you tell the cat to say hello, but you did not specify for how long here, you did not give it how long should this word be visible, you will not be able to see it. But if you tell it, say hello for this long, and then it will be able to say hello in that aspect. Are you clear on that one? Any other question?
Okay, yes, guys, please ask any, this is a time for you to ask questions before we release Mr. John. Sorry, what does not want to move? The cat. Oh, Mr. Krebi.
Let's go to Mr. Krebi's place. Look at my code right here. If Mr. Krebi is not moving, it's because you did not tell him to move. So maybe you did not tell that the right key. Or you put this if statement out of this guy here. Make sure that when you are putting the if statements, these ones here, look at the block where it start and where it end. This is one block for one if statement for the right arrow. And it's under which block? It's under this big block here, because we are only going to be doing this until this specific condition is met. This is a main condition. So now we are telling you that this happens in this direction and we are moving 10 steps only if I press this. Check the code. I think somewhere in the code you probably did not put the right thing there.
Okay.
There are so many games and animations that has been created by a lot of programmers and developers out there. All you have to do is just go to scratch.mit.edu and then you go into tutorials or you go into projects. You will find so many projects that are there which has been done by other students and other teachers out there. You just familiarize with yourself with it, practice more. That's the only way you can be able to understand and know it. It's not a difficult program. It was made for us to actually learn how to program, since we don't really have programming in our syllabus. So this is something that is giving us that platform so that we can learn more about programming at the early stage as you guys in primary schools and high school, so that you can get, when you reach to that point, you'll be able to understand what programming is all about. If let's say
yes, John, thank you so much. Are there any more questions? If there are not any more questions, we do want to wrap up the session.
Thank you. The screen is yours.
Okay. Okay. Okay, I will just share my presentation. Actually, no, I wanted to share. So one of the questions that we could ask is that, remember in the presentation, I did mention that, so let's go to this code. Okay, that this one is more of a visualization type of code, right? But developers mostly, this is the type of code you are supposed to be writing. This one where you see class, hello, public static void main. But so in this case, we are using blocks, but it's also creating codes like this. So the programming languages that you see here, like Python, Java, C++, PHP, JavaScript, those ones are generally codes that are written in line like this. So not like using blocks, etc. So there is another program called Blockly, and it's similar to Scratch. So you still have these things of having blocks, etc. But at least it allows you to change into those other languages. So you can be able to just do your blocks here, and then just copy this this code already that's done for you, and then you go and now run it in any other environment. So this is when now the developers usually code with this type of code. So they don't use Scratch per se with motions and things like that. So Scratch is generally created for us to be able to visualize things and to make it easy, especially for young learners, because it's harder for them to read this type of lines, right? This type of lines. So Blockly combines the two. So you are able to still do your blocks. So like in this case, for example, all I did, I'm trying to do a calculations where I have a function that always sums up two numbers. And okay, maybe let me just do it quickly so I can just put it in the bin. Okay, so I'll put that in the bin. So here you can have variables. You can create your own variables. So you can say maybe X. I think you guys learn more about X. So let's say X, and then we create another variable, let's say Y. Okay. Essentially what we want to is just to say, we perhaps want to give certain things. Okay. So we can say we want to set X equals to 0 for now. And let me go back to no variables. And then, so this one is just the same thing that you were learning with Scratch, but it helps you to put the whatever you are learning in different languages that are actually used in the world right now. Okay. Then we have created two variables, X and Y. We actually just want to run them. They have already created a variable called sum. And then what I can do is essentially I just want these variables. So let me put them here. So I basically want to just add those two variables together. And then let's see if we can say set. Okay. Now I just want to sum them up quickly. So here in this one, you have more of logics, but these ones are pretty much also the same. So it's basically the same things that you would have here, except these ones are more about, so you still have variables, you still have operators, you still have sensing and controls and events, which are almost the same as here, except this one is more like you have logic, then you have loops, then you have mathematics and things like that. Okay. Okay, I could put them in a function so that everything that I do, I eventually just put in one function and then I just play a function. Functions are generally used when you want to, the thing happens over and over again. And that's when we're talking about patterns, so that you are not repeating the same thing over and over again. You just want to have a set of instructions that you can use over and over again whenever you want to. Basically, okay. So I want to maybe say set, not Y. And to change this variable to sum. So we're going to say we want sum to equals to Y plus X. So this is the maths you have. First, I want to just make them 0, and then I want to create a sum where every single time sum would equal to these 2 variables that we have here. And maybe we do want something to kind of print this thing out. So you go to this thing called text, and there's a print function here, or where you basically want to print sum. You want to print the variable sum. So you come and put that one there. And then you can essentially just put these things together. Then we can just change that like to whatever, because variables are placeholders. I think in mathematics you do learn that variables is a placeholder where you can be able to change that variable as much as you want, and then you get various outcomes every single time. So maybe we say this one will be 50, and this will be maybe 60. And then maybe I just want this whole thing to be in this function. Okay. So I want this function to always just create a sum for me. Okay. And with functions, I want this function is called do something. I could change the name of this function and say add 2 numbers or 2 variables. I could name it anything I want. So then every single time I say play, it will tell me the answer here, right? So I could change this to, I don't know, 100, and then I come in and run the code again, it will tell me 160. But the good thing about this is that once I have my blocks, I can change it to whatever language, program language I want, and it will give me the code. And this code, I can then go and use it in other environments, etc. So if you had the game like in Scratch, like what John displayed for us, he had the codes here. If you now do it in Blockly, you are going to have that code, and you can be able to export it to real applications, and you can build real applications now just by using blocks, etc. So this is just the beginning. Once you learn how to use the blocks, then you can scale it up and become a proper developer just by using also simple tools like Blockly, which helps you translate or convert the blocks that you are creating into real code that real developers in the world are using. Okay, so do look at them. I would say look at Scratch first, learn how to do it first, then you can move to Blockly. So that will be your next step if you want to get better. And all these ones, Blockly is used to 100 pro projects. All these websites or these initiatives have been created using Blockly. So for example, Code, which is one of our partners in Africa Code Week. So these guys, let me see if I can just click. So code.org. So if you go to them, the code.org is code.org is an application to help anyone learn how to code as well, and it was created using Blockly. So they basically created using blocks, and then it was changed into whatever language you wanted to use it for, and then they can be, then it's you have that application. And things like JavaScript and PHP, those ones, they can be used to create websites, etc. Do we have any questions so far before we just do the final PowerPoint slides? Hello guys, is anyone there?
Yeah, we are around.
So are there no questions either for me or for John? Okay, I'll assume since it's quiet, there are no questions. Just to finalize the presentation, is that we do have additional resources. As a teacher, if you want to get these slides that we are presenting to you, we can make them available to you. Feel free to contact us. But yeah, if you want to know more about Scratch, go to africacodeweek.org media resources. You'll find a whole lot of resources, introduction to Scratch and Scratch in the classroom. And these are all various coding projects that are going on in Africa and the world. So you can also go there and see those specific links. And then we also have video clips on computational thinking, what is computational thinking all about, and computational thinking lessons. And we also have coding without a computer. So sometimes we do feel limited. We don't have facilities, we don't have gadgets, we don't have equipment, but sometimes you can begin this coding, this concept of coding and thinking without a computer already. Okay. So you, at certain times, you don't need to have all resources, but you can make whatever resources that you have and already start creating your computer thinking skills. Okay, and there are also various coding lesson plans. This one is particularly great for teachers if they want to get various lesson plans so that you are able to teach the learners more on coding and have more coding lessons. Okay, and also just extra tips for teachers. And Google is one of the just one of the foremost companies that are making breakthroughs as far as new technology and new softwares are. So feel free to see Google first. It's also one of the ways in terms of computational thinking and real life problem solving. If you go to Google, they have so many things. It's just not about Google email or YouTube. Those ones are just two applications that Google manages or have created. Other than that, join our community. It's growing very fast. We want to hear from learners. We want to hear from teachers. We always want to be engaging with anyone who's interested in digital skills, coding, etc. in Namibia, in Africa at large. We do thank you so much for being with us and for being attentive. We hope you have gotten some skills. We hope you are going to start creating games, animations using Scratch, and feel free to share them with us, or if you need help, to contact us so that our developers can be able to connect with you and help you where necessary or where possible. Okay. I just give this final opportunity. Does anyone want to say something? Otherwise, then we will close the meeting or the training session.
Good afternoon.
Yes, good afternoon, sir.
Yes, so
Very well, thank you.
Nita,
Yes, sir.
I'm seeing that there's a recording on top here. How are we going to get the recording? Are you going to send us the recording?
Yes, if you have one of our email addresses, simply just request for it. Otherwise, we do just make it available on either our YouTube platform or on our Google Drive platform. But yeah, if you do want to, just send us an email and we'll be happy to send it to you.
No, I gave you my email yesterday. I gave it to the other lady. If you can just send it there.
Okay, okay, sure, no problem. I see there was someone on the chat. Don't forget the form. Okay, please do fill in the attendance form. I believe we have sent it to everyone, but let me just see if I can put it on the chat. Okay. Okay, let me see. Okay, I will. I'm looking for the form link. Yes, but if because we are giving certificates to every learner and every teacher that has attended the training session. So if you haven't filled in the form yet, please do so that we are able to then create the certificates for you and be able to hand them to you. We'll probably give them to the teachers so that the teachers can be able to give them to the learners. I'm just busy looking for that link now. If someone on the team can be able to find it faster. The attendance list, the attendance form.
The attendance form, I did not receive that one.
You did not receive it?
Yeah.
Okay, I'm about to put it on the chat. Yeah, I'm busy just looking for it. Are there any other questions while I'm finding the attendance form link?
Thank you very much.
Or any other comments?
Yes.
Hello, are there no other comments?
No, comment.
Because once we leave, unfortunately, it might be harder to contact us, but as long as you have our email addresses, we are able to connect back to you. But this is your moment to ask if you have any questions, etc.
Any questions? Ms. Njomba?
Are the learners confident? Can they be able to create some of these things we have shown you today? At least make the cat move or something. Will the learners be able to do that?
That's what they are doing now.
That's what they are doing now. Okay.
They are even putting a lot of sound that is disturbing our ears here.
Okay, then that's great. We really do love hearing that. I'm about to just put this thing on the chat now. Okay. Okay, I'll put the link here to everyone. Yeah, I'll put the link of the attendance form on the chat. Yeah, do feel free to just copy it to maybe wherever you need to copy it, because once we close the meeting, then it becomes not available again. But yeah, I'll just give it a couple of minutes so that everyone can copy. Are you able to see the attendance form on the chat?
Yeah, I can see it.
Okay. Yeah, please just copy it somewhere else. And then if you click on it, then you should be able to make sure that everyone has registered or has said that they attended the meeting.
Will do. Thank you very much.
Okay, perfect. Okay, if there are no further questions, we are so thankful to have you. We hope this presentation and training has been of value to you. Feel free to continue engaging with us on our various platforms. If you just look for GLODOM or AHA 2030, you'll be able to find us on various social media platforms or on our website, or go to Africa Code Week.org as well. So you also find information in that regard. But perhaps maybe we could just do I'm going to stop sharing now, but can we just see if we can put up either our videos or something so that we take one picture together, then we can close the meeting officially.
Yes. Which video now do we put together? Okay. Again, I'll mute them. Can you unlock our video as well?
Yes, you can unlock your videos. It's just for us to take one picture and then, yeah.
No, it's closed by that side. Can you open it from that side?
Oh, okay. Now let me open it for you. Is this okay, let me see. That's the start video.
Yeah.
Okay. Okay, let me just take a snapshot and then we are good to go. Okay. Okay, great session, everybody. Thank you so much for tuning in, and yeah, keep coding. Okay, bye, everyone.
Bye-bye. Thanks a lot.